Hi everyone, in today's session we are going to see about performance in computer organization. In this, the performance of the processor can be calculated using the equation T is equal to N cross S by R, where T stands for the processor time required for executing a program or an instruction, and N stands for the number of instruction which is getting executed to complete uh, executed in the entire program, and S stands for average number of basic steps. That is nothing but, for example, if we want to say to add two numbers and store it on the third variable, it has only one line command, but the thing is that the input for the first value has to be getted, and it must be saved onto the memory location, and the data for the second value has to be uh, received. After that, all those both the data has to be copied to the ALU, cache temporary register. After that, the addition operation has to be performed, and finally the result has to be stored onto the final destination location. So consecutively, there are n number of steps which was involved in execution of this basic addition operation. This is the meaning for average number of basic steps involved for execution of the single instruction, and R stands for the clock rate. Each and every operation will be performed in a clock period. Thus, the clock period and the time is denoted as R. Thus, the performance equation calculation by the processor is T is equal to N cross S by R. Let us see what is the processor clock. A processor clock is nothing but it is the circuit controlled by the timing signals, in which the clock signals are categorized of same time interval, in which each and every steps in the instruction execution must be completed within a single clock cycle. If it goes on, the each and every step can be completed within a single clock cycle, so there will not be any overlap of timing signals, and the processor execution will be smooth in pipelined execution. Let us see the execution of pipelining in upcoming classes, and the calculation of clock rate is given here. Clock rate R is equal to 1 by rho. The length rho of one clock cycle is the parameter that affects the performance. If we want to want the performance of the processor to be improvised, the factor that affecting the execution of the program must be minimized. That is represented as R is inversely proportional to P, whereas P is the parameter that affects the performance of the processor, and this is measured using clock cycles per second. And here these are the equations which is used for comparing two systems and the processor execution time, whereas for computer X we are giving it as performance X equal to 1 by execution time. Considerably, if we want to say the performance of the system is greater, the execution time of the program must be comparatively less, so it is inversely proportional. So here it is given as performance is inversely proportional to the execution time. And for if we consider two computers of X and Y, whereas X is having greater performance than Y, then the equation can be represented as performance of X is greater than performance of Y, whereas we have already seen performance is inversely proportional to the execution time. So 1 by execution time of X is greater than 1 by execution time of Y, whereas while converting the denominator into the next side numerator, we will be having execution time of Y is greater than execution time of X. From this we can conclude that if the performance of system X is greater than performance of system Y, then obviously the execution time of a program in system Y must be greater than the execution time of the program in system X. In another way, it is seen as X is faster than Y. In this, the performance is calculated by numbering how much times the system X is faster than system Y. So it will be calculated using the equation performance of X divided by performance of Y equal to N, where N stands for the system X is N times faster than system Y. In this, as we have seen earlier, performance is inversely proportional to the execution time. So performance of X by performance of Y equal to performance of Y, execution time of Y by execution time of X. By replacing the execution time in the formula, we can calculate how much times the system X is faster than system Y. This is the example for calculating the performance of system and comparing the systems A and B.